rhombus, circumscribed, angles, this thing. It's geometry. With me, Miss Cohen.
Guys, just a quick note that at the beginning of the video, there's going to be a demonstration and you do not need to take notes. And then when we eventually do take notes, you'll be doing it on the book that I handed out in class. So make sure you have that ready. And again, the beginning of the video, you're just watching and listening, and you don't need to do a summary for today's lesson. Today we're talking about transformations, and we'll get to our notes in a minute, but before we do that, I just wanted to show you a couple things on this computer program called GeoGebra, where you can do magic. So a transformation is just a function that changes the position, shape, and or size of a figure. And so what I have here is this figure, this green arrow, and that is called the pre-image. That's my original image, and it's called the pre-image. And I can transform it in lots of different ways. In geometry this year, we're going to be focused on rigid transformations, and a rigid transformation might move it around or flip it or turn it, but it will always be that exact same shape and size. So I just want to show you a couple of different ways that I can transform it. So kind of the most basic way is a slide. I can just slide this guy around. So what I have here is, let's see, I'm going to translate this by a vector. So here's my arrow, and I have this vector here, which we'll talk about in a little bit, but basically it's going to slide this arrow in the direction of that vector. And what you can see is that as I, oops, that's not what I wanted to do. As I, let me get rid of this, change this vector here. So right now, the arrow is right on top of itself, but I can slide it down, or I can slide it to the right, or I can slide it to the left, or wherever. But this is called a translation. I'm sliding it around, I'm not changing the size, I'm not changing the shape, I am just translating it or sliding it. And this vector here is kind of telling the computer program how far to slide it. Okay, so that's called a translation, and that's one type of rigid transformation. So let me get rid of that. Can you think of some other ways that I can move this guy around without changing the size and shape? So one way is a reflection. So kind of like looking in a mirror, you see yourself, but a reflection, right? So we can reflect this arrow in lots of different ways. So one way we can do it is we can take, say, this red line down here, that's the x-axis. We can reflect that arrow over the x-axis. And so what that means is I can kind of plop this guy down over here, just flip it down. And so this computer program can do that. I can reflect this arrow over this line and watch, boom, there it is. And you may notice it kind of looks like a slide, right? It looks like I just slid it down. But the key here with the reflection is that like this is up at 4, right? And the reflection is down at -4. It's the same distance away. So that's a reflection. But I can reflect over lots of different lines. Like there's a line, that red line, and I can flip this arrow over that line. So I want you to just take a minute and imagine what that would look like if I flipped it over that line. You can imagine like if this arrow was like heavy, thick paint, and I folded a piece of paper along that line, the paint would kind of like come off on the folded part of the paper, and where would that paint be? So I can show you. It would be right there. So that's the reflection over that line. I could also reflect it over this line. So take a minute to imagine what that would look like.
Okay, imagine.
Okay, boom, there it is. So how close was your imagination? We can also reflect over this line here, the y-axis, and that will look a little funky. So see if you can imagine what it will look like when we reflect that over that line. Everything will kind of flip to the other side. There it is. So it sort of falls right back on itself. And all of those different reflections were, here I can kind of pull them all up. Let me pull up all those reflections that I showed you. So we could reflect it over this line, or we could reflect it over this line. So lots of reflections. But these arrows are all the same size and shape. So a reflection makes a rigid transformation. So pretty cool. So we slid it, that's a translation, and we reflected it. That, oh no, I got rid of my original one. The reflection is kind of a flip. And there's one more type of transformation we can do. So the other one is called a rotation. So I have it set up already. I'm going to rotate this point or this arrow around the origin. This is called the origin. And so basically you can imagine that this arrow is on like a stick, and I'm going to turn it around the origin. Now when we do turns in geometry, we usually move counterclockwise, which would be this way. So not the way the arrow is facing. So right now, I don't know if you can see up here, it says n equals 0. I have the angle of rotation set at 0 degrees. But as I slide this, if it works, oh no. That did not work. Sorry, guys. This up. I need to get rid of that. Okay. So as I slide this, you will see my arrow moving. And it's still the same size and shape. It's a rotation. Okay, and that's 360 degrees. So here we are at 0 degrees. And I can rotate it counterclockwise. I'm going to stop at 90 degrees. 90 degrees. So that's a 90-degree counterclockwise rotation. And I can keep rotating it 180 degrees. And then I can rotate it 270 degrees. And then 360 degrees, it'll fall right back on itself. So this rotation is another way to do a rigid transformation. So we have translations, which are slides, reflections, which are flips, and rotations, which are turns. And those are all rigid transformations because they create an exact copy of the So we're looking at our books about rigid transformations, and first we're going to define what a rigid transformation is. So we'll start with just a transformation. A transformation changes the position, shape, and or size of a figure. So that's what a transformation is. A couple of vocabulary things that are really important. We start with a figure or a shape, and we're going to call that the pre-image. It's the original, the one that we're starting with. And we're going to apply a transformation to that figure of some kind. So we're going to transform it, and it's going to become something new. It might be the same size or shape, it might have grown, we don't really know, but it's going to undergo some kind of transformation, and when it pops out on the other side, we're going to call it the image. So the pre-image gets transformed and becomes the image. And one of the important things you need to know is how to label your points. So usually on a pre-image, we'll have something like figure A, B, C. And A, B, and C would be points on the grid that represent the 3 vertices of a triangle. And then after we do the transformation, we need to name it something different. We can't name it ABC again because that'll get really confusing. So we're going to call it figure A prime, B prime, C prime. And that's better than using new letters because now we know that point A became point A prime, point B became point B prime, and point C became point C prime. So let's talk about what a rigid transformation is. You saw it in the video, but a rigid transformation, they make an exact copy of the pre-image. So the position might change, or the shape might, but the shape and the size will remain the same. So it's an exact copy. There are 3 types of rigid transformations that you saw in the video. The first is a translation. So let's write that down here. You're going to need to write a little small. A translation, and a translation is just a slide. And we're going to draw just a quick version of what a translation might look like. So if we have a little X and Y axis, and I'm going to make a little house here. Okay, there's a little house, pentagon. And if I translate that, I'm just going to slide it somewhere new. So we could slide it up or down or whatever. Maybe I'll slide this one like so along that vector. And it would give me another house the exact same size and shape, just somewhere different on the graph. So that's a translation. We might also see a rotation. And a rotation, more informally, would be called a turn. So let's show a picture of what that might look like. We have an X and a Y axis. And we have, let's make our same little house, our pre-image here. And we could turn it two ways. We can turn it clockwise or counterclockwise. And just so you have this in your notes, clockwise is obviously the direction a clock moves, and we'll abbreviate that CW for clockwise. But normally in geometry, we turn the other way. Normally we turn counterclockwise, and we'll abbreviate that with CCW for counterclockwise. So let's draw an example of what a 90-degree counterclockwise rotation might look like around the origin. So this is our point of rotation, and if we turn it, it's just going to go zoop up here, and it's going to become sort of turned like so. So that would be a 90-degree counterclockwise rotation. And then finally, let's show what a reflection might look like. A reflection, more informally, would be called a flip. X and Y axes. Let's draw our pre-image again, our little house. And we can flip this over lots of different lines as you saw in the video, but I'm just going to show, if I flip it over the y-axis, over there, I hope you can see that that might look also like a translation, a slide. And so I want to make it obvious that what we're doing here is a flip. So I'm going to flip it over the x-axis, upside down, and it's going to look something like this. So those are just little informal examples of the three types of rigid transformations. And what we're going to do now is learn how to perform our own transformations using what's called coordinate rules. So we're going to begin here with example 1. We've got 3 points, A, B, and C. And so the first thing that I would like for you to do is graph those points and then connect them to make a polygon. So please go ahead and do that now. I'll do it too. You can check in with me when you're done. So hopefully you have a triangle. I was looking for my straight edge and I can't find it, but please use a straight edge if you have one. And then it's incredibly important that you label the points, A, B, and C. And remember, this is our pre-image here, our pre-image. And so now that we have our points, we're going to apply this rule. And it looks really complicated, but it's truly not. The best way to use these rules is to write down each point, again, over where you have a little bit of blank space, 1, 2. And we're going to transform it using this rule, and it's going to become A prime. So that's how you want to set it up. A will become A prime. And the X and the Y are going to change according to this rule. So the first thing that you'll notice is that over here on the right-hand side of my rule, in the X position, it says negative Y, right? This is the X position of a point, but it says negative Y. So that means in my new point, in the X position, I have to put negative Y. Now, be aware, negative in this case really means the opposite, right? Because if my original Y is positive, then I'm going to put a negative here. But if my original Y is negative, I'm going to put a positive. That negative, and we might want to write this down, it actually means opposite. We're going to switch the sign. In this case, My y value is 2, right? And so in the x position here, I'm going to take the y from my original point and make it negative, make it the opposite, negative 2. In the y position, I'm going to take the x from my original point and subtract 2. So here's my y position. I'm going to take the x from my original point, 1, and I'm going to subtract 2. And if I subtract 2 from 1, I end up with negative 1. So that is my a prime. And I know that's a little confusing, so let's try it again with another point. So we're going to use b. b is 4, 2, and we're going to apply this rule. So it's going to become b prime. And in the x position of my new point, I need to put the opposite of the y value of my original point. So I'm going to go to my original point. There's my y value, 2, and I'm going to do the opposite, negative 2. The y value of my new point is going to be x minus 2 from my original point. So I take my original point, which is 4, my original x value, which is 4, and subtract 2, right? X minus 2. 4 minus 2 is 2. Let's try it again with point C. Point C is 3, negative 2. And we will apply the same transformation. It's going to become C prime. In the x position of my new point, I'm going to have opposite of the y from my original point. So my original y was negative 2. So here in the x position, I'm going to put positive 2. So it's flipping, right? A negative of negative 2 is positive 2. In the y position of my new point, I'm taking x from my original and subtracting 2. X from my original is 3, and 3 minus 2 is 1. So there's my new point. Once you have your 3 new points, we graph them. So a prime is negative 2, negative 1. B prime is negative 2, negative 2, 2. And C prime is 2, 1. And we'll connect those to make a triangle. Use a straight edge if you have it. And then before you do anything else, label your new points. So negative 2, negative 1 was A prime. Negative 2, 2 was B prime. And then the last one was C prime. So that is a rigid transformation. A couple things happened here. You can see that the triangle is the same shape and size. It's just moved and it's been turned. But there is a rotation that happened here. So let's write rotation. It might be hard to see it, but there was also a translation that happened. This minus 2 means we slid something 2 spaces over. So there was a translation that happened here. But this is rigid. It's the same size and shape. This takes some getting used to, so let's do another example. Example 2. First step, just like last time, I'd like you to graph the 3 points and create your triangle. And so again, if we're going to apply this rule, we need to make sure we write down our original points. So A was negative 3, 1. By the way, if I'm going too fast, feel free to pause. And that's going to become A prime. So I just have to follow this rule. In my new x position, it says take your old x, add 4. That's it. So I'm going to take my old x, which was negative 3, and add 4. Negative 3 plus 4 is 1. In my new y position, it says do 3 times your old y. 3 times my old y. So here's my old y, 1. And I have to do 3 times that. So 3 times 1 is 3. And there's A prime. Let's do point B. Negative 1, 2. We're going to transform it using this rule, and it will become B prime. I want you guys to try it on your own and then check back in and see if you did it right. Okay, hopefully I gave you enough time there. If not, pause it. So this rule says in the x position, take your old x, add 4. So here's our old x, negative 1. And I'm going to add 4 to that. Negative 1 plus 4 is 3. And then here in my y position, it says take your old y, multiply by 3. So my old y is 2. 2 times 3 is 6. So there's my new point. Let's try C. That will become C prime. Go ahead and do it and then check back in. If that's not enough time, pause it. I'm going to take my old x and add 4. So my old x is 1. 1 plus 4 is 5. I'm going to take my old y and multiply by 3. 1 times 3 is 3. So there are my new points, and now I just need to graph them. A prime is 1, 3. B prime is 3, 6. And if I'm going too fast, please feel free to pause. C prime is 5, 3. And there's my new figure. Sorry that I don't have a straight edge here. So that's A prime, B prime, C prime. And I want to take just a minute to label that this is our image. Sorry, this is our pre-image. And we can write old. And this is our image. New. Okay? And then looking at this, if we can try to figure out what happened, this is non-rigid. So let's write that. This is non-rigid. I hope you can see that it got stretched. It's not the same shape and size as it used to be. It got stretched. So the pre-image was kind of short and the image is a little bit taller. So this is non-rigid, and what happened with this guy is it got moved, right? All the points got moved a bit, so there's a translation that happened, a slide. And there was also something called a dilation, and a dilation is just a stretch. We're not going to talk much about dilations because those are non-rigid transformations, and in this unit we're really focusing on rigid transformations. This was a lot of information. You don't need to write a summary today. If you did not understand these examples, I don't want you to freak out. This is hard. It takes a little bit of getting used to. And so in class next time, we're going to practice it a bunch and you'll feel really confident. And at this point, you're done with notes for today.